We'll continue now with section 1.7 on our problem solving or linear application problems. Now we'll look at some mixture problems. In mixture, quantities are combined or dilutions are changed. Let's look at example 3. Ben wishes to blend candy selling for $1.60 per pound with candy selling for $2.50 per pound to get a mixture that will be sold for $1.90 per pound. So some cheaper and more expensive candy selling it for some price in the middle or between. How many pounds of each should be used to get 30 pounds of the mixture? Now, this is to be done where revenue doesn't change. He's not going to make more money out of it. It's just a matter of taking the two different blends and mixing it in together into one mixture. Okay, so what do we know? We know we're trying to find how many pounds of each. So let's let x, we'll have our variable x be the pounds of the $1.60 candy. Okay, and what do we know about our total? We know that the total pounds that we want to end up with is 30, right? So what expression can we use for the $2.50 candy? Well, if we're going to add x to some number and get 30, then take the total, subtract off the $1.60 candy, and that must be the pounds of the $2.50 candy. So we're just trying to find an expression for each. Remember, we did that with the principal, P1 and P2. Okay, same idea here. So we have a total of 30, so if we subtract off 1, we must have the pounds of the other one. Okay, so without any change of revenue, what this means is, well, on one side of our equal sign, we'll have the two different piles of candy and their prices, and on the other side of the equal sign, we'll have the mixture. Okay, so we have $1.60 candy, and we have X pounds of that. We're going to add that to the $2.50 candy, and we have 30 minus X pounds of that. Now remember, each one of these terms has to be the same. This is money times pounds. Money times pounds. The last one, we need money. How much will the mixture sell for? $1.90. And how many pounds did we have of that? 30. So there's your linear equation. We have to use equations to solve these, right? We could have played around with it, but the idea is to learn how to use mathematical models, set up an equation. Okay, so now it's just a matter of distributing and combining like terms and solving for x, right? 250 times 30, that's 75, minus 2.50x, and this comes out to be 57. So combining like terms here, what do we get? Negative 0.9x equals negative 18. Divide both sides by negative 0.9, and we get x equals 20. And it said how many pounds of each. What did we find? We found x pounds was the pounds of 160. So we need 20 pounds of the $1.60, and we need how much for the 250? Well, we can do that in our head, right? The total is 30, so 10 pounds of the 250. Okay, so what this says is the original way they were selling it was separately. If we mix them together and sell it for $1.90, that's how much we need for each one for this to be equal. Selling it as a mixture is the same as selling it separately. Okay, let's look at another one. It's similar, but just has a little different part to it. We have a health food store that wants to mix dried apricots and dried apples and have this mixture that they'll sell for $1.67 a pound. The apricots are $1.70 a pound. The apples are $1.10 per pound. How many pounds of dried apricots should be mixed with 2 pounds of dried apples? Okay, 2 pounds. So we know how many pounds of apples we have to ensure no change in the revenue. Okay, it's not going to change just because we're mixing it. We're going to, as we sell it, we'll end up with the same amount of money. So again, let's look. What's our x going to be? Well, it's clearly x equals pounds of the apricots. That's what we're looking for here. What is our what else do we know? They actually told us 2 is the pounds of apples. So the total pounds is what? They didn't give us that, right? If they gave us that, we wouldn't even have to work the problem. If they said it was 5, we'd know x was 3, right? But the total pounds would be, of course, x plus 2. Now we put it in with the money. Money times pounds plus money times pounds equals money times pounds. Okay, for the apricots, it was, what? Apricots were 170, and we have x pounds. Apples were 110, and we have 2 pounds. The mixture, 167, and we have x plus 2 pounds. Okay, 170x plus 220 equals 1.67x plus, and what's that, 334? 3.34. Okay, and then we have 0.03x, subtracting 1.67x from both sides, subtracting 2.20 from both sides. We get 0.03x equals 1.14. Divide both sides by 0.03, and we get 38. So we need 38 pounds of apricots for this to work.